Decarbonisation in Europe means building the electricity grids we need to connect renewables to our homes and factories. At the same time, the disastrous impacts of climate change like fluctuating temperatures, floods, droughts, and wildfires are intensifying and accelerating. To prepare for these impacts, the grid must adapt and become more resilient. A big task. How do we achieve it? This is Adaptation and Resilience. Climate-proofing the grid. Let's take a look at floods. These can be caused by heavier, more frequent and unpredictable rainfall over flowing waterways and urban areas, or rainfall after periods of drought. Recent examples in Europe include Germany and Belgium in 2021, and Italy and Croatia in 2023. Over a quarter of Europe's power generation capacity may be affected by floods if the climate warms between 2 and 3.5 degrees Celsius. These floods can also damage power lines, substations, and hydroelectric dams, or affect cooling systems needed for some electricity sources.
2 years ago, one of our Belgian substations at Pepinster was quite damaged via floodings. And last year we had another substation in Flanders that was also quite damaged. And therefore we are also analyzing what is the asset design we need in the future to be able to cope with hot weather, with floodings or with storms.
When we talk about climate adaptation, it can sound very abstract, but it isn't actually. It's about understanding today's risk and future risk, and really starting to think through of how we can make our processes, our assets, our business activities all more resilient, not just in terms of dealing with a heat wave today, but also dealing with a heat wave in 10 years, 15 years.
The good news is that we can build a climate-proof electricity grid. By assessing local climate risks, we can apply tailored and innovative solutions such as deploying fire detection systems, strengthening existing grids, or undergrounding electricity cables. These strategies can help mitigate the effects of storms, fires, or heavy snow and should be scaled up and applied when appropriate. We can also operate the grid smarter. Smart grid technologies provide electricity system operators with more information and data. This allows them to make better decisions faster. Grid operators can then respond quickly to sudden, fluctuating or extreme weather conditions and keep the grid online.
Are we using data and information and science to anticipate what can happen and share data and information also across the whole system so that we all understand where the risks are and can take action early? Early warning is an important element in that.
That's why it starts at the very beginning when we're doing now our new scenario analysis for the future, where we're doing grid simulations to be assured that we're developing the grid in the way that is fit for future. We are now considering all these climate impacts that we unfortunately will have in the future.
Then there are also questions around making the assets more resilient by investing, for example, in higher poles or different kinds of transmission services that are more resilient to heat. So it's a real mix of solutions that we need to apply, and they need to be very location specific to address the risks that we are facing in those regions.
At the same time, we need to improve how we maintain and restore the grid, because changing climate conditions and extreme weather events can cause damage no matter how well we prepare. Ensuring there are enough spare parts for repairs, trained workers, and vehicles to reach damaged infrastructure alongside emergency response strategies is therefore vital.
One element that is more important than ever also to be resilient and to be reliable is what do you do in case you have some severe damages. And there as well, you have to increase your preparedness to recover quite quickly in order to stabilize the grid again.
Interconnectors can also help us address the impacts of climate change and strengthen the entire European grid. interconnectors are power lines between national grids. So when one country or area experiences an unexpected or extreme weather event, one of their European neighbours can step in to help. For example, in the cold winter of 2017, interconnectors helped European countries share electricity to prevent power outages. Mitigating the effects of extreme and changing weather patterns on grid infrastructure also means that climate change impacts need to be reflected in grid planning and modelling. For that, we need more data, better tools, and most importantly, for energy system planners, climate scientists and modellers to work together. We can only realise these changes with collaboration, transparency, and by recognising the needs of diverse communities. RGI is continuing to actively learn and engage with partners and our members as this topic evolves. For more information on climate adaptation and resilience and the grid, check out our website at renewables-grid.eu.